includes 10 different sub-questions. Excuse me. Each of them worth 0.2 points each. And we'll work a couple of them. I think we'll work just 3. It says the dominant type of intermolecular force for this molecule is, and of course it just lists all of them. And what you need to know is that the dominant type of IMF is the strongest one out of these 4. So if it's LDF is the strongest intermolecular force, then you'd have to circle or check this one. If it has dipole-dipole forces, then that would be next, all the way down to ion-ion. And it's at this point I will remind you, and I haven't said this today, but it was in the lecture video, LDF, all particles have LDF. However, nonpolar molecules, it is the only intermolecular force. So nonpolar molecules only have LDF. So if you have dipole-dipole forces because you have a dipole in your molecule, you also have LDF, and it's like the dipole-dipole forces add something to it, and that's why we're using the term dominant. It's the strongest one, and you also have LDF. Anyway, I'm not sure if that makes any sense. Jump in any time if you have questions or you want me to talk more about it. But in the meantime, I'm going to start solving this first question. It says the dominant type of IMF for this molecule is, and so the key here is you're always going to want to draw the Lewis structure. Draw the best Lewis structure, LS. And once you see that, if you were to draw CH3, you recognize that COOH group as something that we were just talking about. And at this point you would say, well, I have a hydrogen covalently bonded to oxygen. And I have a lone pair of electrons on oxygen. I have both parts of what I need to do hydrogen bonding, and so you would circle hydrogen bonding here. And it's true, there's a dipole over here, but hydrogen bonding is more dominant. It is stronger than either of the ones listed above it. That's why we circle hydrogen bonding. For question 2, it says the dominant type of IMF for PF5. And for this one, I'm going to contrast PF5 with BrCl3. Because the big question on these molecules is, are they polar or nonpolar? And to figure that out for sure, you have to draw the Lewis structure. And I'm going to quickly go through this. If you were to draw the Lewis structure for PF5, you would find, if you count up all your electrons, distribute them to all the fluorines, and I'm going to draw all the dots. You would find that there are 40 valence electrons in this molecule, and that if you put 5 fluorines on phosphorus, you will use up all 40 of those electrons. And whatever dipoles there are, and there are dipoles in this molecule, but because they're all the same, this will be a nonpolar molecule. And since it's nonpolar, its biggest IMF would be LDF. Right? Nonpolar molecules, it's the only intermolecular force they have is LDF. Now, in red over here, I'm going to do BrCl3. BrCl3 is going to have Br and 3 Cls, and then when you sprinkle your electrons around, you'll see there are 8, 10, 12, 14, 16, 18, 20, 22, 24, but there are 28 electrons in this Lewis structure. So you end up putting 2 more pairs of electrons on the central atom, which means the dipoles here will not cancel. And for this molecule, this is a polar molecule. And the dominant type of intermolecular force for BrCl3, what I guess we could call bromine trichloride, would be dipole-dipole forces, if this question was about that. Any questions about question 1 or question 2? All right.
Professor?
Yeah, Daryl.
In bromine trichloride, is a dominant force LDF or is dipole-dipole?
Good question. So this molecule is polar, so it would be dipole-dipole. And the reason we know it's polar, so we could draw dipoles on this, they would actually be facing the chlorines. And those dipoles would not cancel out because there are 2 pairs of electrons, and so there's no like dipoles up in this direction. Whereas all 5 of the dipoles here are in exactly opposite directions, so they would cancel. Let's do question 3 and then we'll take a break. Question 3, it says the dominant type of IMF for this molecule, and I'm going to compare it to this molecule here. So let's see, this is going to be methyl chloride, and this is going to be carbon tetrafluoride. And I don't know about you, always draw the Lewis structure if you have any questions. But what you can start to see is that this molecule, methyl chloride, has a carbon-chlorine bond with a dipole that doesn't cancel. This is a polar molecule. While CF4, I should draw F's there, not H's. CF4, it has dipoles as well, but all of these dipoles will be in exactly equal and opposite directions. So it is a nonpolar molecule. So for the molecule that we're asking about, since it's polar, the answer would be dipole-dipole forces as the dominant intermolecular force. And for CF4, it's nonpolar. Nonpolar molecules have LDF as their dominant intermolecular force. Any questions about that?